Hello YouTube. So today I just wanted to make a video about this little thing that I made right here. What it is essentially it is a uninterruptible power supply, but it's for USB. So basically, what an uninterruptible power supply is that you have a main source of power. Usually, it's like a outlet, and then you have a battery which would go to a power inverter, and essentially if there's a power outage, a relay in the uninterruptible power supply will flip and it'll switch uh, from the main power, which is now out. It will switch to the inverter power being powered by the battery. So what I have here is sort of like that, but instead of using 120 volt AC, it is using 5 volt DC. So essentially, this is the schematic right here, and here's the actual circuit. Here's the battery, and here's the load. You can see this light is being powered by it. Uh, I'm actually using a similar light for filming, so yeah. So what this circuit really has is there's your main power supply, and you have a battery, and then there's a load and a relay as well. So just to display this, when there is main power, so when this is activated, when there is main power being supplied, the relay will flip to this position, and then the load is being powered by the main power. So if it is if there's main power, uh, then the relay will flip, and the load is powered by the main power. That is also done because the relay has a 5 volt input and a in, which basically just says to flip the relay or not, and those are all coming from the main power. So if there's no main power, the relay cannot flip because it has no power, and it also cannot flip uh, because this in will not be uh, activated. So like this in it's active low, so it goes to this inverter, and yeah, so that's also set up here. You probably don't really even need that just because the main power to the relay will be cut off, but whatever. Uh, this circuit does work, so that's what we have right here. And when there's no main power supply, the relay obviously will not trigger. It will be in its off state, and when it is in its off state, it will be powered by the battery. So the battery will power the load. And also, another important thing is the transition between main power and battery power, and vice versa. That relies on this switch being fast. Because, well, like let's say I unplug the load, it turns off, and now I plug it back in, it's still off. So this is kind of picky about uh, interruptions in power. You can't just unplug and plug it back in. It will not turn on again. So uh, that just for like this light, but you get the point. It's bad to have interruptions in power. You want the continuous supply of power. So I don't know how they do this in like normal UPSs. Those are delivering AC power, which is more complicated. But since this is delivering DC power, it's simple enough. Just add a capacitor here. So essentially, this capacitor is always being powered up by the main power right here. So when the main power is disconnected, the capacitor will discharge, and that will give the relay time to flip to the reserve power, and then that will discharge the capacitor again. And when main power is restored, it will flip back to it. So yeah, that's pretty much all the elements right here. Now I could show the circuit. As I mentioned, here's the capacitor. Uh, Here's the relay. We are only using this relay really, And here's the inverter circuit. As I mentioned, it may not be necessary because uh, when the main power is cut off, the relay has no power, so it just will go to the default state, which is this wire, and then this wire is going to this battery right here. Also, we can charge the battery, and the battery is being charged by the main power, and that's another thing right here. So when main power is activated, the load is powered by the main power, and the battery is being charged up. So this kind of depends on how your battery is set up. This battery, what it will do is, right now it's charging, and if we want to draw a load, it will stop going from the charging and it will power the load. Also, another thing to note is that the power lines here just go to the main power. The ground is shared between the main power and the battery, so that's how it works. But the plus 5 volts is always charging the battery, it's not being supplied by it. Also, these two wires are shorted out, the data wires right here. Sometimes you might have to do this just so that the battery knows to supply power. So let's demonstrate what it does. So as I mentioned before, the load is plugged into this USB outlet, and we are also getting power from this computer power supply. So what if, for example, we switch this off? Let's see what happens. So as you can see, the relay switch very fast, and the light is still on, and it is drawing down the battery. So let's say what happens if we restore main power, and you'll hear this come back on. Alright, so now the battery is charging again, and we should be able to unplug this. This relay is not very good, so it might disconnect, but it shouldn't. Ideal circumstance. So now the battery is unplugged. So we know that essentially when the main power is off, the light will be powered by the battery. But when the main power is restored, the battery will not be drawn down. The load is powered exclusively by this power supply right here. And obviously we could put it in a situation where it can't recover from, where there's no main power and there's no battery, and it turns off. So yeah, that's just a demonstration of this USB UPS thing. You can see we can connect the battery and turn it back on, and it switched back on. So yeah, this is the circuit which I have made, a USB uninterruptible power supply. You could pause the video if you want to read this, just the information that I went over. And yeah, so what would this really be useful for? Obviously, normally a uninterruptible power supply supplies mains voltage 120 volts AC, and you could use it to power a computer. You could save your data, log off, that kind of stuff if there's a power outage. Well, what could this be used for? Well, in this kind of situation where it's in this prototype, you can't really use it for very much. These wires are kind of very fickle. If you push them, it'll disconnect. But you could probably make a circuit where you could plug in a flashlight or whatever into the wall, and then you can just unplug it and it'll still be on. So that might be a use for it. And notice how you don't have to mess with plugging something in the battery or plugging the power in. It just does that automatically via the relay. If there is power, the battery will charge, load will be powered by the power. But if power is disconnected, the the relay will automatically say, okay, now we're going to draw down the battery. If power is restored, we'll charge the battery again. So it does this kind of automatically. Uh, this is a very simple circuit. So yeah, I might do something with this. But I just wanted to show this with you. And it is almost 3 in the morning, so I'm going to go to bed. But see you next time, and thank you for watching. Turn this off. And thank you for watching.